Well, hello, and welcome back to another episode of Quantitative Bites. It's great to see you all. I hope you're doing well. I've come outside to have my morning coffee, good excuse to get a little bit of fresh air on a pleasant day before starting work for the day. I think it's important, particularly in these times when we're all supposed to be at home as much as possible, to get fresh air while we can. I want to start a new series today and another small project that I want to document my progress on, and I just wanted to say that, one of the things that I've always hoped to achieve with these videos is that they might be inspiring to at least some of you out there to go and build your own things, to create your own sort of small projects. I think one of the key ways as developers or software engineers or coders or whatever, whether you do it professionally or not, one of the key ways to really hone your skills, to develop your skills, and at least to keep your skills current is to just continually build new things. And that process of continually building small projects and finishing them is, I think, really critical, really key, to developing and learning as a developer. And I think it probably applies to other areas of work as well, not just software. I think one of the important things with that, of course, is to finish things. So, if you're doing small private projects at home, regardless of what you do, professionally, I think it's important to pick projects that are the right size so that you can finish them. The 80-20 rule really comes into it. The final 20% of any project usually ends up taking 80% of the time, right? So actually pushing a project through to completion is really an important part of doing that, I think. One of the things that I've really enjoyed about making this YouTube channel, and one of the things I feel that I really get out of it is the perfect excuse for me to do exactly that, to go and actually to develop small little projects, just for their own sake. I remember when I was younger and when I first started to get into computer programming, I would write code just for its own sake. It wasn't to solve a problem, it wasn't necessarily, sometimes it was, but it wasn't necessarily to solve a particular problem or to do anything particular. I would write code just for fun. And I think sometimes it's very easy to lose that sense of joy, that spark of fun that you can have from coding. It is such a pure act of creation. It is literally willing something into existence using nothing but the power of your mind. And I think that's incomparable. I don't know of anything else really that is perhaps like that. Maybe painting or art like that perhaps has the same feeling of pure creation. I'm not sure. But I found that since working professionally as a developer, or at least developing software professionally as part of my career, I found that it's very easy to lose sight of that spark of fun, and making these videos and pursuing these small projects that I've been doing for these videos has really allowed me to reconnect with that, and I think that's great. And if I could, inspire at least some of you out there to reconnect with that initial joy of programming. I'm guessing most of the people watching my videos are kind of into programming already. And if I could inspire at least some of you to reconnect with that joy, with that sense of fun that programming can give, then I would be very pleased. Yeah. Anyway, I wanted to just start a new small project that I'm going to pursue, kind of devlog style, a little bit like we did with the 2D primitives library in the earlier videos. But my coffee is nearly coming to an end, so I suggest let's go inside and let's have a look at what this project will be. Well, it was great to get a bit of fresh air with my morning coffee, but I think probably better to come back inside in order to explain what this particular project is. So what I decided I wanted to do, in keeping with the whole idea of just continuing to make little small projects and things really for my own sake, in order to keep my skill set sharp and keep my skills honed, I decided it would be kind of cool to take the 2D primitives library that I developed before. I'll put a link up here so you can go back and watch that series if you want to, and combine that with the work I did with the discrete Fourier transform in the previous two videos. Again, put a link here so you can go and look at those if you want to create a very simple spectrum analyzer app, an app that will take a signal in the form of a WAV file, or perhaps even from the microphone. I don't know about that, we'll see how we go, and display a spectrogram of that signal, perhaps in real time. Again, we'll see how we go. Not sure at the moment. So this is what I've decided to do, and I thought, well, that would make quite a good series for this channel. And as I say, it's in keeping with my philosophy of really just trying to do things that will inspire at least some of you out there to go out and build more stuff for yourselves, either you know, something similar to what I'm doing here or something entirely different. Just, it's up to you. Really, I'm really just hoping that perhaps, you know, I can inspire you to continue to build more things. And most importantly, as I said at the beginning, to finish things. That's really the key thing. It's one thing having small private projects, but really the critical thing is to finish them. So whenever I start a small project like this, I always like to go through the proper design process, even if the project is actually very small. And I think that's really a good exercise, because in software engineering or coding or whatever you want to call it, actually sitting at the keyboard and bashing out code is not the only skill that you need to have. Now, of course, when you're developing projects just for yourself, it's fine to do that. You know, you don't necessarily need to take all the sort of completely professional approach to things. But when I start a small project, I like to do a little bit of that kind of pre-planning, just to get a feel for how I think things are going to fit together. It's probably going to change over time, but it's still worthwhile just to sort of get your brain thinking in the right direction before you sit down at the keyboard and start writing code. Yeah, again, you know, of course, it's just projects that we're, you know, building just for ourselves. It's just for private use, whatever. You know, no one cares if you change the design halfway through or do whatever. You know, yeah, it's up to you. But what I've come up with, well, this is how I like to do it. I use my whiteboard, my trusty whiteboard, and I sketch out the architecture diagram that I think I'm going to use. So that's what we have here. So I've never shown these before, but I thought it might be good to show you exactly how I go about planning a small project. So each of the boxes here simply represents one of the 4 classes that we're going to use initially. Like I say, this is all subject to change. This is just the initial plan. So we have the CApp class, which is the main app that controls the application. So it implements the main methods. We have methods for execute, initialize, and tick. So we'll talk about those when we go and look at the code in a moment. The CApp class will create at least one instance of a SpecPlot class. Now, the SpecPlot class is going to be the class that actually manages plotting the spectrogram, and it will create instances, at least one instances of the rectangle class. So we're going to use the rectangle class there to actually produce the bars. So we're going for kind of like a bar chart display, I think. So it makes sense to use rectangle. So the rectangle class, of course, comes from the 2D primitives library that we developed before. And of course, naturally, it inherits from the object class there. Okay, so we saw this code for rectangle and object. We saw that in the previous series that we did on the 2D primitives library. So that is the broad outline of what I want to do. And I think it probably becomes more clear when we go and look at the code that I've produced so far. As before with the 2D primitives library series, this is really intended to be more of a devlog rather than a tutorial series. So, you know, this is all subject to change, and I just really wanted to document my progress with creating this app as something that I'm just putting together for myself. Simply, as I say, because I hope it might be inspiring to you. So don't necessarily take this as a solid tutorial on how things should be done. And, you know, this is really me. I'm working this out, you know, sort of as I go along just as much as you are. So what I will do is at least once a week, I'll post a video about my progress over the previous week running up to that video, and we'll see how we go. It's not a big project, so it's not going to take too long to finish. I think maybe 2 or perhaps 3 episodes, and we should be pretty much there, but we'll see how we go. Anyway, as I always say, if you like this video, please remember to hit that like button. If you haven't subscribed to my channel already, then please consider doing so. I do try to make videos roughly once a week, so if you subscribe, then you don't need to worry about missing anything. Thank you very much. Anyway, let's go to the computer, let's have a look at the code, and let's see what's going on. Okay, so the first thing I wanted to look at really is just how I've gone about structuring the code that I've created so far. And what I've done is created a specific directory or folder for this project, into which we have, of course, capp.cpp and capp.h, and we also have main.cpp and our make file, because I'm using gmake to manage my projects. That's my preferred way of doing things. You can use cmake as well if you wish. I prefer to use gmake. Within that folder, I then have 2 subfolders, one here, qblib2d. Now that contains, if we go into qblib2d, that contains all of the files there from the 2D primitives library that we developed before. There'll be a link to that in the description below that video series there. So I'm not going to talk about that in any great detail, certainly not today. The other folder that I've created is QB and if we just have a quick look in there, I'm not going to talk about all of the contents of here for now. This contains all of the specific working code for this particular project, so everything to do with the spectrogram plot that we intend to make. So at the moment, the files that we want to talk about are specplot.cpp and specplot.h and qbspeclib.h as well, which is a master header file. qbdsp.cpp and qbdsp.h, these are still really under development, and I'll probably talk about those in the next video rather than talking about them now. So that's essentially the structure that we have. What I want to do first, let's just have a look through each of these files, and hopefully it will be useful to you to see sort of how I've gone about implementing this. The first thing that I want to look at, this is the make file for gmake. So I've talked about gmake before in previous videos. Now this is my preferred way of managing, building all of my code. If you don't know what gmake is, very briefly, it's a build managing tool. It just allows you to manage building all of your code. So as if you were not using gmake, you'd have to write out long commands to compile the code, like something like this, and then all of the various subfiles. Whereas by using gmake, all I have to do is type make, and that will go through and that will build all of my code, as you can see here, as follows. Right, we don't need to watch that finish. That just goes through and it pulls out all of the separate files and compiles them. So this is kind of cool because it means that we can point it to these folders, qbspeclib and qblib2d, and it will automatically go through those and find any new files, any new CPP files particularly that we've put in, and will automatically add those to the list of objects. So when I did the 2D primitives library, I talked about this way of doing make files before, so I'm not going to talk about it too much here. I will put a link to that in the description below, so you can go back and have a look at that. Otherwise, pretty much everything is as we've used it before. So we set our libraries. We're using SDL2, so we have libs equals -l SDL2. Link target, of course, is main. That's going to be the name of our main file, and we are specifically using C++17, so we set C flags to that. And we define the various objects, indeed the object files that we want to compile. We have main.o and capp.o, and then, of course, as I've just said, these commands here go into these two specific folders and pull out the necessary files automatically, so we don't need to list every file individually. We define our rebuildables simply as being the list of objects and the link target that we've defined there. And then we have the rules that actually manage the building. Rule 1, this actually does the final compiling, the linking specifically into link target with objects, the libraries and the C flags, and Rule 2 is responsible for compiling each of the CPP files and header files into the necessary .o files, the object files that will then be linked together. Like I say, there's a more thorough description of that in one of the previous videos, so if you're interested, go and check that out. Next really is main.cpp, so very little code in here. This is really kind of just a standard way of doing things as I understand it for SDL2 applications. This implements just int main here, the entry point of our code, and we simply create an instance of the CApp class called the app, and then we simply run the execute method within the app, within the CApp class, and that's it. So let's have a look at CApp itself. This is the header file, capp.h. So this hash includes obviously SDL2, and we're going to use the vector class from the standard library, and we also bring in qblib2d.h. that's the master include file for the 2D primitives library, that's described back in that series, and we bring in the master include file from qbspeclib as well. And then here we define three, well, I suppose we have obviously the constructor for our class, and then we define three public methods: execute, initialize, and tick. We'll have a look at those in a moment. And then we have these various private properties to store the X and Y size of the window, a flag to store whether the code is running or not. And then we have these two pointers here to point to an instance of SDL window for the window, and a pointer to an instance of SDL renderer for the renderer. And we create a pointer to our SpecPlot object. So as you remember from the architecture diagram that I showed just now, we are going to create a class called SpecPlot that is actually responsible for plotting everything in our window according to the particular data that we have. So we create a pointer to an instance of that class here. And if we look in capp.cpp, This does standard include things in the constructor. We just set things up, set the window and the renderer to null, and set the isRunning_flag to true. And the execute method, this is the function that's called immediately. If we look back in main.cpp, the first thing this does is run the app.execute, okay? So if we look here, this is the execute method. All this does really is handle the main loop of our code. So we create an SDL event object or instance, and we call the initialize function to set everything up. We'll have a look at that in a moment. And then this while loop here, this is the main loop of our code, so this will run continuously until the isRunning_flag is set to false. And the only way at the moment that is set to false is if we detect an event of type SDL quit, which happens when the user presses the close button on the window, and then all we do is set isRunning_flag to false, and that will then cause, the next time through this loop, it will cause this loop to drop out. And when we drop out of that loop, we know it's time to end our code. So the first thing that we do, if the SpecPlot class, an instance of the SpecPlot class was defined successfully, in other words, it's not null PTR, then we delete it. And then we go through and simply destroy the window, set window to null, and call SDL quit to tidy everything up. So the initialize function, this is pretty basic. This just uses the SDL init everything function to set everything up. If that was unsuccessful, it returns false. We define our window using SDL create window, window title, spectrogram. We've talked about those things before in previous videos. And then we create a renderer instance pointing to that window called mRenderer. And then we use SDL get render output size from that renderer to store the X and Y size of the window. We know what they are anyway, but in the future we might wish to allow the user to resize the window, so it makes sense to do it that way. And then we simply create an actual instance of our SpecPlot class here using this syntax here, create new QB_SpecLib : SpecPlot mRenderer, and 32, that is the number of bins that we're going to plot, and we'll talk about that in more detail. So that's pretty much everything for, well, no, it isn't actually. The one last thing then to talk about in capp.cpp is the tick method. So if we look back at our main loop, we see that each time through this while loop we call tick, and tick is responsible for updating everything, including updating the screen. So every time we come through here, we set the render draw color to black, we clear the window to black, and then we're going to call the render method on our instance of the SpecPlot class, and then we use SDL render present to actually update the display. And then we have a small delay here so we don't max out a CPU core for no reason. And basically that's it. That's the core structure of the code that I'm using. It's really pretty simple. I think what I want to focus on really is the SpecPlot class and what I've done so far with that. So if we look at specplot.h, the first thing we have to do is, of course, we have to hash include qblib2d.h because we're using the 2D primitives library that I created in the previous series. And then we put this inside the QB_SpecLib namespace, which just makes things a little bit tidy. It means, you know, we have QB_SpecLib : SpecPlot, so this is specific to this namespace, which is just, I find, a nice way of doing things. And then this class has a constructor and a destructor. The constructor accepts as input a pointer to an SDL renderer object, and also takes an integer representing the number of bins that we want to plot. So that's the number of, we're going for a kind of bar chart quite type of display. So numbins is going to be the number of bars that we want to display across the width of our window. And we have a destructor, SpecPlot, we'll look at the code for that in a moment. And then what I've done is to find a method for set data. Now, and this takes a single parameter called data, which is a vector of complex doubles. And my thinking is that what we will do is every frame of our animation, whether we do this in real time or not, I'm not sure yet, but for every time we want to update our plot, what we will do is use the setData method to simply pass a new set of data, and then the SpecPlot class is going to take that data and create the relevant plot accordingly. And then we have a render method that is actually responsible for rendering the display, the spectrogram display to the screen. At the moment I haven't defined any private functions, so we don't worry about that. In private member variables we have a instance of SDL renderer, or a pointer to an instance of SDL renderer. We have our object list, so because we're going to create more than one bar for our display. It wouldn't be really very interesting if we had only one, so we will create multiple bars for our display. So we store those in a vector of pointers to the object base class. If you look back, think back to the architecture diagram that I showed just now, remember that the rectangle class inherits from object. And because we want to maintain the option to put anything into this array, not necessarily rectangles, it makes sense we create this as an array of pointers to the object base class, and then we can actually put rectangles in there or triangles or whatever we see fit. We then just have internal variables for the x size, the y size, the number of bins, and of course bar spacing. We don't necessarily want each of the bars in our plot to be exactly next to each other. It looks kind of cool if we have a space between them, so we have bar spacing to allow us to do that. Now if we look at the CPP code, so SpecPlot.cpp, obviously we hash include SpecPlot.h, and we have our constructor. So this does really most of the work at the moment. So this is really just initial fleshing out of this code. It's not really in its final version at the moment. So this is the constructor. We just talked about the function declaration now. So the first thing we do is simply store the parameters, the renderer, pointer to the renderer, and we store the x size and y size of our window. For now, we set the bar spacing default value to 2, and we calculate the width of the bar objects for the display, which is simply the horizontal size of the window divided by the number of bins. And then we need to compute the width of each bar, which is going to be bin width minus 2 times the bar spacing. 2 times the bar spacing because, of course, we have bar spacing on either side. So this gives a total spacing of 4, but 2 pixels on either side of each bar. And for now, we're fixing the height at 1/2 because we're not allowing the user to pass any actual data into this anyway at the moment. And then we create the bar object. So this is probably how I'm going to do it, at least initially. So we simply loop I from 0 to I less than number of bins, and then we calculate the left width, height, and bottom coordinates of the rectangle. If you remember back from the 2D primitives library episode where I talked about rectangles, they are defined as on the basis of a left, bottom, width, and height parameters to define their position and size. So we calculate those accordingly. Width is obviously bar width. Height is simply going to be the bar height multiplied by y size. So bar height is designed to vary between 0 and 1. So we multiply the vertical height of our window by that to get, and static cast that to an integer after rounding it off. That gives us our height. And then we calculate bottom as being y size minus height, because with SDL2, a y coordinate of 0 actually represents the top of the window, not the bottom, and we want the bars to come up from the bottom. And then we simply create a new instance of the rectangle class from QBLib2D with those parameters, and we loop through that accordingly, and that will generate all of the bars that we need. The destructor function, we do need a little bit of code in here, so assuming that we've actually created some objects, we then just loop over every object in that list and we delete them just to make sure that we tidy everything up. Set data, currently I've left that blank, so this will be the method that will take the data, and that will force the display to update to represent that new data every time. And the render method simply checks that we have a valid pointer to a valid renderer defined, or a valid pointer to a renderer defined. Assuming that we have, we then just loop over every object in the object list and call its relevant render method. So the rectangle class implements a render method that is responsible for actually drawing it, so that will create the display. And actually really that's everything. If we go back to our terminal window, we ran the make command to compile everything just now, so we should be ready. So if I run the code, then we get this display. There we go. So really not terribly exciting. So we've created a window that's titled spectrogram. Let's just line that up. There we go. And within that, we've created 32 bars, which their height was set to 1/2. So they go from the bottom of the window up to the halfway point, and they have 2 pixels between them on either side. In fact, so that should be the spacing. There should actually be 4 pixels. And there we go. That's everything I've done so far. It's not tremendously exciting, but it is just the beginning of this project. So over the next week, I'm going to continue developing this, and we're going to see what we can do to make this actually accept some real data and actually produce a proper spectrogram display for that data. I'm probably not going to get as far as making this animate in any way before next week's episode, but well, we'll see how we go. We'll see how we go. yeah, that's pretty much everything that I've done so far, but I think that sort of gives a broad overview of how I go about structuring a project like this, particularly the way that I like to organize my make files for Gmake, and then the structure and layout of CApp, which is the main class responsible for implementing the application. And then we've looked at what I've done so far with the SpecPlot class, which is going to be the class that's really responsible for doing all of the work. It's quite a lot to do there. As I say, it doesn't do anything terribly exciting at the moment, but we'll get there. I think it's a reasonable start for this project. Okay, so that's really everything I want to talk about this week. I really hope that's been of interest and useful to at least some of you out there. And as I said at the beginning, really my objective with these videos is to be inspiring. You know, I would really love it if I could inspire at least some of you out there to just go out and create your own projects, maybe doing something similar to what I'm doing, or maybe doing something entirely different. The whole thing is just that it's really important to keep practicing, I think, with any skill set as a software developer or indeed anything else. And I think building lots of small little private projects yourself is really one of the very best ways to do that. You know, so that's really my objective. Anyway, really hope you've enjoyed this video. If you've liked it, please remember to hit that like button, and if you haven't done so already, please remember to subscribe to my channel so you don't have to miss any future videos. I do try to make a video roughly once a week. I don't always achieve it, but I try. And yeah, if you subscribe, then you don't need to worry about missing anything. Anyway, there we go. It's been a great deal of pleasure making this video. I hope you've enjoyed it. Let me know in the comments below what you think. It's really great to hear from you. And yeah, otherwise, I really look forward to seeing you in the next video. Thank you very much for watching. Bye.